Hello everyone. In this video we're going to be integrating 1 over 1 plus cosine x. I know, some of you are already saying, well, this is too easy, I can do this with my eyes closed. But I'm going to show you two methods, and the first method is a little painful, so bear with me on that one, but it's a really cool method because it applies to different situations as well. So let's go ahead and start with the first method. I'm going to be presenting two solutions, two methods, and let's start with the first one. Okay, and why am I introducing the first method? Why is the first method painful? Because we have the adage, we have the saying, no pain, no gain. Okay, let's get started. So this substitution involves that I call something like this: z equals tangent x over 2. Now, this may not be meaningful to you, but you're going to notice that this really simplifies the integral to a really cool state. So from here, if we inverse tan both sides, we're going to get x over 2 is equal to tan inverse of z. And of course, I can just multiply both sides by 2 here. X equals 2 tan inverse of z. And then I can just d both sides. As you know, dx is found from x by taking the derivative and then multiplying by d whatever. So in this case, to find dx, I'm going to differentiate tan inverse of z and multiply by 2, of course. So that's going to give me the following. That's going to be, what is the integral of tan inverse? It's 1 over 1 plus z squared, but I have to multiply it by dz, so it's going to look like this. Let me go ahead and write it down, and let's not forget the 2 here. There's a 2 here in the numerator, and if you want to write it separately, that's fine too, but I'd like to write it in the numerator. So let's go ahead and write it as 2 over 1 plus z squared multiplied by dz, and of course you could write it as 2 dz over 1 plus z squared, and that's going to be my dx. But that's not what I all need. I need more than this. Since I want to get to cosine x, I could definitely use the, the double angle formula here, but I just want to find tangent x first because it's fun. Let's go ahead and find tangent x from here, and let's see how that goes. Since I already know that tangent x over 2 is equal to z, remember the formula for tangent 2 alpha. It is 2 tan alpha over 1 minus tan squared alpha. And we use this formula, in some of our problems. Remember that? So now, in this case, then I can safely say that tangent x is 2 times x over 2. So I can safely say that this can be written as 2 tan x over 2 divided by 1 minus tan squared x over 2. And since I already know that tangent x over 2 is equal to z, I can write this as 2z over 1 minus z squared. Now, why did I find tangent x? Because I'm going to show you something real cool here. We're going to draw a right triangle, and let me show you. This is really fun. So this is going to be my angle x, and tangent is going to be 2z over 1 minus z squared. Now, if you use the Pythagorean theorem, you're going to find that the hypotenuse is 1 plus z squared. So that's kind of like a nice identity we used a lot. Remember, in our geometry puzzles especially, 1 minus z squared, z squared quantity squared minus 1 minus z squared quantity squared is equal to 2z quantity. Anyways, that's kind of confusing. But anyways, you get the idea. This is a Pythagorean theorem. From here, cosine x happens to be adjacent over hypotenuse, which is 1 minus z squared over 1 plus z squared. As I said earlier, this is a painful method, but it allows me to find cosine x, and I have dx, and that's all I need. So let's go ahead and put these together. What am I trying to solve for? dx over 1 plus cosine x. So I'm going to replace dx with 2 dz over 1 plus z squared, and I'm going to replace 1 plus cosine x with 1 plus the expression 1 minus z squared over 1 plus z squared. And let's not forget the integration symbol. Now, this expression obviously simplifies, as you know, because that's the purpose of this type of substitution. Notice that the denominators are both 1 plus z squared in this case. So when you make a common denominator, they're going to cancel out. But what am I talking about? I talked too much. I apologize. Let me go ahead and simplify this a little bit more, and then I'll explain what I mean. So we're going to divide this by now. When you make a common denominator, multiply 1 by this. That's going to give you 1 plus z squared. Plus, now I have 1 minus z squared here, and that is going to be divided by 1 plus z squared. And I'm going to integrate that. I know this may look very complicated. Why are we doing this? Because at the end, it'll be very simple. Okay, so first of all, notice that 1 plus z squared and 1 plus z squared is going to cancel out. That's cool, right? But not only that, we're going to get much more than this. Notice that z squared minus z squared also cancels out, and 1 plus 1 is equal to 2. 2 divided by 2 is equal to 1. So all of these are going to cancel out as well. See how that kind of collapses? And we end up with what? dz. All right, great. Now, what do you know about dz? Well, the integral of dz is just 1 dz. You can basically write it as 1 dz. And what is the integral of 1? 1 is a constant, so you can pull it out. But if you do pull it out, then there's nothing left. So let's leave it there. Well, here's the question you need to ask. If you're integrating the function, 1 is the derivative of what? Well, it depends on the variable. But in this case, I have a z. So the integral of 1 dz is going to be z plus c, because the derivative of z is 1. Make sense? And constant c, don't forget that, otherwise you're going to lose points. Your teacher is going to be real mad at you. Okay, so don't forget the constant c, and that's my result. But what was z? We kind of lost track, right? Well, z is equal to tangent x over 2. Awesome. So let's go ahead and back substitute that, and we're going to be getting the result of this integral. I know we complicated things, but isn't that fun? At the end, everything simplifies so nicely and justifies this method. So the result is going to be tangent x over 2 plus c. And that is the end of the first method. So let's go ahead and use our second method to solve this problem. And obviously, since you've been through the painful method, you deserve to see the less painful method. And here's how it looks like. Okay, so I'm going to be using for this method, anytime you see something like 1 plus cosine x or 1 minus sine x or 1 plus sine x, you should think about double angle formulas. Why? Because it allows you to simplify them. Let me explain what I mean. So cosine of 2 alpha can be written, as you know, there are 3 formulas for it, but I'm going to use the one that has cosine in it. And that's going to look like this. Cosine 2 alpha can be written as 2 cosine squared alpha minus 1. Now, if you replace 2 alpha with x, that means then your alpha is going to be x over 2. So we can also write this equation as cosine x is 2 cosine squared x over 2 minus 1. Now, that's super duper helpful, because what I can do is I can just go ahead and substitute that here. And notice how helpful that's going to become. Well, what is dx? I don't care. dx is dx. But I'm going to replace cosine x with this, which is 2 cosine squared x over 2 minus 1. Now, what is so cool about it is that the 1 and the negative 1 is going to cancel out, leaving us with something nice. And what is that thing? Well, it's 1/2 times dx over cosine squared, but 1 over cosine squared is equal to secant squared. So why don't we just write it as 1/2 multiplied by secant squared x over 2 dx. Now, if you remember the formulas for integration, the integral of secant squared is tangent, because the derivative of tangent is secant squared. But we have an x over 2. So what are we going to do? Well, if this bothers you, you can just go ahead and do a quick u substitution. Say that x over 2 is equal to u, x is equal to 2u. Allow me to say that. And dx from here is going to be 2 du. So that allows you to write this as 1/2 of secant squared u times 2 du. But I can pull out the 2 here and put it there, which means that the integral of secant squared is just going to be tangent u plus c. Again, don't forget the constant, and this constant doesn't have to be the same as another constant, but anyways, this is going to be the result. But u is equal to x over 2, so I can just go ahead and back substitute, and this gives me the integral of dx over 1 plus cosine x, one more time, as tangent x over 2 plus c. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.